Now, for our first session for tonight, uh, the world of Spark in Azure with Warner Chaves. Warner is a principal consultant. Actually, not anymore. He's a solution architect for Pythian. He's an MVP for data platform from Canada, and he's also a Microsoft certified master. And with that, I would like to pass the control now to Warner.
Thank you, Pio, for the intro, and thanks everybody for joining today. At these, I guess it's dinner time for you guys. It's early breakfast time for me. Yeah, so you guys will see I put it up here in my coffee. All right, let me share my screen. And all right, World of Spark and Azure. Thanks everybody for joining me today. Allow me to introduce myself. I've been working for Pythian for quite a while, and I've been a DBA and consultant for 15 years now. I used to work for HP. My Microsoft Data Platform MVP, as Pio mentioned, you can see all my contact info there in the slides. I can share the slides with Pio later. The slides are very short um, because I really wanted to spend most of the time just showing you demos instead. And feel free to connect on LinkedIn as well if you use LinkedIn. I usually add everybody that attends my sessions just to keep a wide LinkedIn network. Okay, the agenda, I'm just going to do an intro, all different ways that we can run Spark in Azure and demos, because this is something that comes up quite a bit with people who have big data workloads, and they say, well, why do I use this service, or when do I use this other one, or when do I use um, Synapse, or when do I use HD Insight, et cetera, et cetera. And some of them are better than others in different ways, and we can see what they look like, how they operate, and so on. Now I'm going to do a quick intro now, just to cover some Spark concepts, then the different offerings in Azure for Spark, and then we'll do demos. And like I said, very little in terms of slides. We'll just go straight into demos very soon. So prerequisites, I think, for jumping into Spark on Azure, just basic experience with databases and SQL. Nowadays, Spark does a lot of SQL, so you get by pretty well. If you do know programming, obviously it's a lot better because you can run Scala, you can learn Python. I think learning Python would be great anyway, if you don't know any Python right now. If you are interested in the big data space. So that's the only other thing. But truly to get started, you really only need SQL. All right, and then just basic knowledge of warehousing, ETL, big data, because these topics always come up all the time when you're doing data engineering or big data analysis, right? So it's good to have those foundations. But other than that, I think a lot of people really um, get intimidated by the big data Spark ecosystem, and it's not that complicated. People should be able to jump in. So first, what is Spark? All right, so this is a timeline. Uh, some of you, if you've been veterans of the big data space, Hadoop was first released in 2006. Back then, it was the HDFS file system and a bunch of different tools to be able to do something with that file system, right? Java libraries to be able to run MapReduce jobs. Um, you guys remember there was this other way of writing jobs called Pig. People would just load everything with Scoop. Um, then Hive came out shortly after to provide like the tabular interface. And it was a very fragmented ecosystem, right? Even though Hadoop surprisingly did have quite a bit of adoption at the beginning because it was like the first time where you could run big data analysis on non-proprietary systems, right? Before that, it was mostly gated by having tons of money to spend on licensing for large appliances like, Teradata or Netezza or something like that. And then Spark version 1 released in 2014. The idea there was to take that fragmented ecosystem of Hadoop and just refactor it into one platform to do everything, right? One platform to rule them all. So Spark would do Scala, Python, SQL. The promise was that Spark would do structured data with tabular support. It will be able to load and parse unstructured data as well and semi-structured data, and it will be able to do streaming too at the same time with the same similar API and interface, etc., etc. So this is what Spark delivered, and ever since it came out, so it's been 7 years now, it had really become the de facto open source standard for big data, right? And it has continued to be very, very well developed and supported. Spark version 3 just came out last year with a lot of internal improvements. For example, adaptive query processing is now part of Spark, so it's a lot smarter about how it generates these big data execution plans. It can reevaluate on the fly to improve the plan and so on. So very still powerful and very large ecosystem. Very simple architecture diagram here, just to everybody to get on the same page, just in case, again, you're not super familiar with Spark. So this Spark is a distributed system by nature, right? So the idea is to distribute the compute in a horizontal way. And so instead of just getting beefier machines, you add more nodes as well, right? And you can do a mix of both, right? If you have a workload where you would benefit from more memory locally, then you beef up the nodes. Maybe you don't necessarily add nodes. If you will have a workload where you want to increase the parallelism, then you add nodes into it, right? There's a main node called a driver that runs a program with a Spark context. And the program could be a job, or it could be a notebook that is executing commands interactively. Then there's a cluster manager component. And cluster managers, they can be different ones. Usually there's Apache Yarn, for example, is the most popular one, and distributes the work to the nodes. The worker nodes run tasks, which are the actual pieces that go out and fetch data and do something to the data. And then they communicate back to the driver node to do something. Um, Something interesting is that, like I put here in the slide, this can use local, remote, or cloud storage. So at the beginning of time, when Hadoop came out, the architectures that people built were almost all using local storage for the compute nodes, because people were using creating these big HDFS clusters, right? And the idea was that, oh, we're going to crunch the data close to where it is. So we're going to create these massive HDFS clusters, and then um, that's how we're going to get the velocity. And then obviously over time, this kind of value proposition got eroded because of the cost of this way to keep storage, right, and the maintenance associated with it. So people started to do remote storage with their Hadoop as well. So they would have just nodes for compute, and then storage, let's say, in a remote SAN with some fast network connections. And then, as the Hadoop got adopted by the cloud providers, and Amazon got really successful with S3, and Azure has blob storage, and now has the data lake storage as well. Google has the Google Cloud storage as well. So the architecture nowadays is for people to mostly just use cloud storage as their data lake, and then have different engines of compute to work on that data, right? And Spark would be one of those engines. So the value proposition of Spark, right? So it's open source software, portable across platforms. So if you write something on vanilla Spark, open source Spark, it will run across any platform, across cloud providers. Obviously, you'll have to, you switch from Azure to Google. You might have to switch from blob storage to Google Cloud Storage. But other than that, it is portable, right? And keep in mind, not all the flavors of Spark are open source, and we're going to go into that. Spark already has implicit data parallelism and fault tolerance, so you don't have to change the way you program to be able to get parallelism and fault tolerance. Spark already does that for you. So you don't have to tell it how to read the data in parallel or how to compute it in parallel. It will already have that built into its execution plan. And it has a built-in fault tolerance as well. So if a node goes down, Spark can reassign tasks as well. You don't have to handle or do special handling of those types of issues in your code either, right? It has multiple programming interfaces, as I mentioned before. So, if you are familiar with SQL, then you can get up and running with the SQL commands. If you want to really unleash the full power of Spark, though, you'll probably be looking at learning one of the big programming languages of Spark, which is either Scala, Python, or Java. Most of the examples online of actual Spark programming, you'll find them in these three languages. Scala being the one that is actually, um, I find most examples online. Maybe you can find they're either Scala or Python. So keep that in mind. Python right now, according to some of these popularity websites, is the most popular programming language in the world. So PySpark is very well supported. And like I said, if you don't have a, if you want to learn one of these and you want to figure out where to start, starting with learning Python is probably a good idea. And then there's thousands of libraries. So that is just, a huge value proposition because most likely, if you want to do something, there's already a library out there that does it. It is a huge amount of libraries built for Spark, and not just for Spark. There are also a huge amount of libraries built for Python, for example, right? And then it works transparently through Spark. You can bring Python packages into your Spark cluster and incorporate them to your programs, and it will allow you to just bring in any sort of library to do extra compute that you don't have to write yourself, right? So obviously it's a huge value proposition to say you don't have to write all these things from scratch, just use the Python's built-in libraries as well, right? Same with Scala, if you bring in Scala libraries, etc. Okay, so here we go to the different flavors of Spark. So nowadays you usually find these three different flavors. So there's open source Apache Spark. This is the package that you can download from the Apache Foundation. There's Cloudera. Cloudera is still a publicly traded company. So I think it trades in the NASDAQ. So it's still very much out there, even though we don't see it as much anymore. At least at Pythian, we don't. Um, some of you might remember there was a company called Hortonworks that was the only one that developed a Windows flavor of Spark, and they got acquired by Cloudera. So now it's only Cloudera. But I think there's also a few, maybe they're still out there. There was another company called MapR that had a proprietary Spark distribution, and I haven't heard of them for a long time. So I don't think anybody's using that anymore. When I say anybody, obviously there's probably somebody, but it's not popular. And then the other one that is getting very popular, so it's the opposite, is Databricks. And Databricks, we'll go into detail in a little bit about it, but Databricks is a cloud-only version of Spark that mixes open source Spark, or not mixes, it's built on top of open source Spark, but adds a bunch of proprietary stuff, right? So Spark in Azure, three options: HD Insight, Databricks, and Synapse Analytics. So those are three different ways, three different services that you can use to run a Spark workload. So HD Insight is basically a managed cluster. So you pick from different options. Not all of them are Spark, actually. You can pick, for example, you want an Apache Storm cluster for event processing, and that's done through HD Insight as well, right? So it's more of a Hadoop ecosystem cluster, managed cluster offering. There is no built-in environment. When I say that, what I mean is that you get the cluster and that's it, right? So as we go in the demo, you'll see, Spark and Synapse especially, they provide an ecosystem of other tools around Spark so that you don't just get Spark and that's it, right? But that's not what HD Insight is, right? It's just you get a cluster, you figure it out kind of thing, right? It's pre-configured with the basic stuff, like the libraries necessary to check on cloud storage and stuff like that. But other than that, it's just a bare bones cluster. So also that means that there's no cluster automatic lifecycle management, which means that if you need to submit a job, you got to create an HD Insight cluster, and after the job is over, you got to destroy it. And next time you want to submit another job, you got to create it again, and then you got to destroy it. Or if you want to, you can just pay 24/7, right? But most people don't want to do that. And also most people don't want to wait for the cluster to start either. So in my opinion, HD Insight, I mean, back, if we had this session 4 or 5 years ago, This was the only option that you had, right? You either use HT Insight or you run your own container or virtualized uh, Spark cluster yourself, right? So it would be more of an IaaS solution. But nowadays, there's very little value proposition, I think, into running HT Insight anymore. Databricks, on the other hand, is a proprietary service and code on top of Spark, right? So Databricks is something that you have to pay for. It's a separate service built on top of Spark. And some of the people that work at Databricks were actually some of the people that worked developing the open source Spark as well. They're also known for being the developers of the Delta Table Lake project. The Delta Lake is a type of table that adds features to Spark that are not included on the open source Spark implementation. So for example, with the Delta Lake table, you can do time travel. So you can see, oh, what did this table look like? I don't know, let's say a month ago, and you can do that with a Delta table on Databricks. You can do atomic acid transactions on a single table, not multi-table, but you can still do it on a single table with Databricks, which you can't do in Vanilla Spark. And what else does Databricks does with Delta table? Well, it does a bunch of stuff. On the proprietary Databricks, it does a lot of things. But Databricks also publishes an open source version of the Delta table so that you can work with that as well. Oh, Delta tables also support both streaming and batch workloads in the same table at the same time too. So that's pretty cool. And then there's like I said, Databricks builds proprietary stuff on top of Spark, right? So Databricks has some heavy optimizations. For example, they created a new engine for running SQL. They call it Tungsten, which doesn't run on Java, right? It runs on C++. So it's a lot faster than the vanilla Spark SQL engine that is developed on Java. And then Databricks is also, they are the top proponents of the Lakehouse architecture. This is something that maybe some of you have heard about, Lakehouse architecture. And basically what that means is that Databricks says that you don't need a data lake and a warehouse to be separate. You can just use open formats like they do. Obviously, this is basically a pitch from Databricks to use their service so that everything is just one spot. So instead of having, some files on data lake that get access through data lake and then a copy of that data in a structured warehouse that you then query as well, just leave them in the data lake and then use tooling like Databricks Tungsten SQL engine to be able to query them really fast and um, and not have to have copies of the data basically. But this is a big topic, though, obviously, not really in the scope of the session to go into what the lakehouse architecture is, but that's pretty much what it is. And then Databricks also has a built-in environment, which includes ML capabilities built right into the environment as well. Sorry. All right, so Synapse is the last one. One little break. Synapse is Microsoft's top analytics service. So Synapse was debuted. I think the public preview of Synapse came out fall of 2019. Fairly recent service. It hasn't even been 2 years, maybe 2 years now. That Synapse has been up there in Azure. And the idea of Synapse was to blend Spark with Microsoft SQL's MPP engine. So this is the engine that Microsoft used to call Azure SQL Data Warehouse, that it used to call PDW on-prem, if you ever worked with that, and then it got rebranded to the APS, the Analytics Platform System. I don't know if anybody still buys that anymore. They shouldn't. They should just go to Synapse at this point. But anyway, that's what Synapse does. And what they do is they take open source Spark and they have done some modifications on the Microsoft side to optimize for Azure. And these are mostly under the covers optimizations. So they have done like some query optimizer fixes for Spark and some internal modifications so that they get better performance. But the layer on top is still mostly, for the most part, is open source Spark. So unlike Databricks, at Databricks, some of the stuff they do with Delta tables, it is truly proprietary, like you would not be able to take that code and run it outside of Databricks. The open source Spark that Microsoft has, you would be able to take that code and run it on any other Spark, because again, the Microsoft modifications have been under the covers. They haven't been to the top surface layer, like the programming surface layer of Spark. And then obviously, a big value proposition of Synapse is that it's integrated with the rest of the Synapse workspace. And I'll just show you guys real quick once we get to the demo for Synapse, like what the Synapse workspace looks like, right? Then it just has so much tooling, right? So it's if you are a big proponent of Azure, if you're all bought into, you know, you want to stay on Microsoft services and Microsoft platform 100%, then Synapse obviously is very attractive because it just bundles everything, right? And that's it. That's all I have. So let's just go into show you guys the three options: HD Insight. I'm not going to create an HD Insight cluster, but I'll show you guys the portal and Databricks and Synapse. So let me switch to my environment. So this is HD Insight. This HD Insights cluster. You say create an HD Insight cluster. And then we'll just, not even gonna create anything anyway. Just filling this up, cluster name, test, cluster. Pick a region for the cluster. And then we pick a cluster type, and you'll see here all the different cluster types, right? So this is what I mean when I say that HD Insight is more of a menu of the Hadoop ecosystem, right? So you guys can see here at the top, I have Hadoop. So I can just create a vanilla Hadoop, like old school cluster, right? You guys see here. And it's got the MapReduce engine, Hive, Pig, Scoop, and Uzi. Then I can create a Spark cluster. I can create a Kafka cluster instead on HD Insight if I want to. I can create HBase. I don't know if you guys ever use HBase. It's a NoSQL database built on top of HDFS. You can do an LLAP with Hive cluster as well. And then you can do Storm, for example, for the streams. And then, oh, they have a new one here, ML services, R server. I've never even tried this one. But anyway, you guys can see here, right? So you have a bunch of different stuff you can run on HD Insight. And it just so happens that Spark is one of the workloads that you can run there. So let's say I can select Spark. And then I can select what version of Spark I want. So the most popular version of Spark that you'll find right now out there is 2.4, which is the most stable release of Spark before 3.0 came out. And depending on some organizations, maybe they haven't yet upgraded or started to use 3.0. So most of it, you'll probably start to see, if you start to work on Spark, you'll see a lot of people still run 2.4. And you can see even HD Insight here, Spark 3.0 is in preview, right? And then you just have to, you know, put your username, login, password, and um, let's just put something here quick. Get all mad at me. Hey. Oh no. Mm, okay. So many rules. Alright. You guys see here? All right. So then I go into the storage bit here on HD Insight. You can pick primary storage to be Azure Storage, would be Blob Storage, or Azure Data Lake Storage Gen 2. You can pick the storage account that you want to put in there. If you want to have that Azure Data Lake Storage Gen 1, if you adopted that, you can add that as well. You can add external metadata stores if you want. If you want to store your metadata outside of the cluster, for example, then you can do that as well. You can add here, for example, the type of network configuration that you want as well, if you want to place it inside a VNet, etc., etc. And then you can have the configuration here, which is what a lot of people just look for here. You have your head node, zookeeper node, worker node, and you can add more stuff here if you wanted to, right? You want to add an application, then, for example, you can add some stuff like, for example, H2O if you want some ML services there as well. But again, the experience is mostly very much like an IaaS type of thing. You pick everything exactly the way you want it, and you get the cluster created, and that's it, right? And then you're on your own for the rest of the ride, other than the integration with like the storage that they pre-configure for you. That's pretty much it, right? Okay, I'm not gonna create it, but this is pretty much what you get, right? So it's just vanilla HD Insight. Now, Databricks, on the other hand, is a full environment, right? So you guys see here right away the difference between that and Databricks, right? So Databricks also provides three different dev environments. You guys will see here at the top. One is what they call data science and engineering, which is the initial environment, let's call it, that Databricks came out with, which is an environment just targeted for running notebooks against data, right? And that's why they call it data science engineering. So let's see, for example, you can go here, you can configure different databases, you configure different tables, you can add clusters as well. For example, you see I have this cluster right here. It says ML cluster with no GPU, and go into the definition of that cluster. And you see here, for example, this is a cluster that has Spark 3.2. It has auto scaling enabled. Notice here how this cluster, for example, is configured to terminate after 10 minutes of inactivity. So this is something that you don't get with HD Insight, right? As I mentioned before, HD Insight is you create it and that's it. It's up and running. You gotta destroy it, or it's still gonna stay there, burning your compute, even if you don't need it right away, right? And you can select different type of machines for your workers, for the driver node as well. And you can set limits here, right, for minimum workers, max workers, and so on. So this is how you can define all these different clusters in Databricks, and you can also assign them to different people as well, right? So you can do some workload management too by saying some people have access to this cluster, other people have access to these other clusters, and so on, right? So that's part of the Databricks, the value proposition as well, right? If you go to the workspace, you can see there's the ability to have shared notebooks. You can have notebooks that are owned by the different users. This is my user, for example. And you see here, right, they have different notebooks as well that I can run, right? And some of them will be more of a data engineering workload. Others could be more related to ML, for example, right? So let me show you, for example, if I go into this, for example, is more of an ML notebook, and you'll see here there are some integrations that Databricks has to the ML functionality. So I noticed that I opened the notebook just here in the data science and engineering workspace, because it just opens a notebook anywhere. But I'm just going to show you here. It does have these other two kind of like modified environments. So you see here, if I switch over to the ML, then I get a slightly different panel here on the side, right? So I can go into experiments, and you see I ran some of this the other day, so I would have it populated. And you see I have this experiment that I ran before. I can go into it, and then it gives me all the different things that I did with this particular experiment, different machine runs, um, with the different metrics of each run, and which one was the most accurate. And this is all done through the AutoML built into Databricks' ML flow as well, right? So this is, again, this is one of the value propositions of Databricks, is that there is a lot of integration here between Databricks and um, um, the ML. And under the covers, it uses something called ML Flow. It's an Apache project as well. You can, this is, I haven't used this yet, but I saw the other one. I guess it's in preview right now. It's basically a way to add feature tables. So these are the tables that you would use to do your ML training model and to collaborate with them, right? So, if you have a data engineer and some data scientists, the data scientist could ask for a particular definition of a feature table. Data engineers can create them, and then they can be shared and reused, and you can have jobs to run against them. You can also store the models as well. So you see here, right? I have this particular model. You can see the versioning of the model. So you see I had two versions. Every time a new version is used or is created, is registered, you can see it in the GUI. You can see this version has already been archived. This is the version that is considered production. So when I would call the libraries inside Databricks that say, hey, give me the wine quality model, it will automatically pick the production one if I don't specify that I want anything specific, right? So that's built in as well into Databricks too. Okay, and the latest thing they introduced is the SQL workspace, and you guys will notice right away the environment is slightly different, right? So you get here. Um, it's a very different type of environment. They have invested into making this more interactive. It's definitely not in the range of, you know, it's not going to turn, it's going to start a cluster here now, I think, to show this dashboard. So I'll have to give it, see if it, how long it takes. Might take a couple of minutes. But anyway, I'll just talk while this is happening. So this is an investment that Databricks did. I believe they bought a company called Redash that had a visualization dashboarding solution to create this type of thing. Mostly, I think, is competitive pressure from something like Synapse, for example, right? And the necessity of Databricks to have like a rich visual environment. By no means is it a competitor to something like Tableau or Power BI. Is not there, right? But if you just want to have some quick dashboarding, quick visualizations, then this is what they're offering right now, right? So you can see here, these are loading. Um, so let's wait and see. In the meantime, I can show you, for example, this, let's say this says daily fare trends. This is the famous New York taxi um, sample data set. You actually look at the queries. So you can see here, they're waiting for the SQL endpoint to start. That's what we're waiting for. So just to show you again, here you can see these are the sample data that you can load, and you can see it's all SQL based, right? So there's nothing special here. It's all SQL based. The idea again on this SQL new experience inside Databricks is that everything that you want to do, you could just do it with SQL here, and it has under the covers that newer engine. However, this advantage here, say Databricks to something else like Snowflake, for example, which is kind of like Databricks is trying to compete with, in my opinion, with this type of thing, is that it's still a lot slower to load than, let's say, a Snowflake cluster, right? So you guys can tell right away, right? We've been waiting a minute here for the SQL endpoint to start. The SQL endpoint is nothing other than a cluster under the scenes that has an endpoint that understands this the SQL queries that you send from Databricks, right? And you guys can see here where a minute and 12 seconds, 13 seconds, and we're still waiting for the endpoint to come up. So I'm just going to leave this now. Maybe we'll come back and check it out after the endpoint has started. So on the other hand, we have Synapse. I'll show you here. And Synapse is just a lot of stuff in one, right? So this is the Synapse home. And Synapse comes integrated with tons of stuff, right? It has SQL databases. It has a Lake database. I'm missing my serverless. Let me refresh this. There, now it's there too. Yeah. So it has this SQL DW is a dedicated pool instance, and this demos is serverless. So it has two different SQL engines. These Lake databases, these are the databases that I have created with Spark. So it's integrated in Synapse, is not just integrated, just running Spark and that's it, which is basically what this is under the covers, right? 2 minutes still. And in Synapse is you get the Spark and the data lake and also the distributed SQL. So that's an extra point for Synapse. Now, obviously, Databricks, like I said, they try to propose to people that they should just do the lake house architecture and just have one thing, right? You don't need two engines, just use one engine and do a lake house, right? But as I said before, Databricks, the main problem right now it has is the fact that it's not super fast to spin up Spark clusters compared to just spinning up SQL engines. So, so I don't know how feasible Lakehouse is yet for most people. If you do go to manage, then you'll see here Apache Spark pools, and that's where you can create the different Apache clusters. So it's called a pool. It's just a fancy name for a cluster. So you can give it a name. You can say here you have either memory optimized nodes or hardware accelerated nodes. So these are nodes with GPUs. You'll see here there's it goes from small, so four cores with 32 gigs, all the way to double X large nodes. These are 64 V cores with 432 gigs of RAM. That's a lot. It's almost half a terabyte of RAM. And you can increase the number of nodes. Right now, mine, you'll see it's set to 3 minimum to a 10 max with auto scale. This can be brought up all the way up to 200 nodes. Now, I think if you try this, in the portal, I don't know if it's even going to allow me because 200 nodes times 64 cores, I'm pretty sure that would blow up my quota of cores inside Azure. But if you are a big enterprise, you can just call support and say, hey, please enable the flag to let me run a 200 node Spark cluster in Synapse, and I'm sure they'll do it for you as long as you're willing to pay for it. Now, honestly, the cost doesn't seem that bad to me. People might think I'm crazy for saying that, but it says estimated cost per hour is 282 Canadian dollars an hour. That's probably around 240, 250 US an hour. And people say, "Oh my God, how this is not too expensive? It's 250 an hour or whatever." But keep in mind, these clusters are ephemeral, right? So you wouldn't run a 200 node cluster 24/7, right? You would run it for a particular job or particular ML process or a particular report that you need to compute maybe once a week or once a month or something, right? And then if you have that much data that you do need a 200 node cluster, then not necessarily spending $500 on a temporary cluster to run it for 2.5 hours, it might not be that bad in terms of cost, is what I think. But just keep in mind, because people see this, right, and then they think, oh my God, but that would be so expensive to run it monthly. But it's very unlikely you would run this the entire month, right? Most likely you would run it for a few hours and just stop after a few hours, right? It wouldn't be running forever. All right, so this card, I'm not gonna create that. I don't want to blow up my subscription. And then the other thing is just to show you the rest of the integrations of Synapse. Let's see if this finally started. Oh, there we go. So you'll see the query is done now, right? So this is the SQL. You get here the results. You can add visualizations if you want. So it's got a little editor to add visuals. It's got a bunch of different types here. All right. So again, this is kind of like Databricks is try to compete with some of what Synapse and Snowflake are doing, where they add visualizations right there in the environment. I close this and close this. Sure. Let's go back here. Oh, wait. Dashboards. There's my sample dashboard. I already had this one. Oh, here it is. Okay, so I got my SQL endpoint running now, so that's why this is populated now. So you guys can see here, right? So creates, somewhat interactive. It's not too bad. But again, it's not supposed to be a replacement of something like a Tableau or Power BI in terms of actual visualization and BI capabilities. But if you're just looking for something to do some quick dashboarding and to run some queries on your SQL queries on your Delta tables or your data lake storage, then it's good for that. You can see here I have this endpoint, and this endpoint, like I said, under the covers is a SQL endpoint is just another cluster, right? So this is like the way for Databricks to run SQL as well. All right, I'm just gonna skip right back into Synapse. And then the other tools that are here available inside Synapse, again, this is something that is kind of like competes with Databricks as well. You have other stuff, right? Like Synapse also has the notebook experience. So I can open like a Spark notebook, right? You guys can see here, right? I have different notebooks as well. The Synapse experience, you can also have, it's tabbed. So you can switch back and forth between different notebooks and different tabs. Did this load it? No. And by the way, the SQL endpoint in Databricks, it was a preview for a long time now. I don't know if it's still considered preview or if it's GA now. But anyway. Yeah, and then you can run notebook stuff inside Synapse as well. Keep in mind though, Synapse also offers yet more stuff here in terms of pipelines, right? So you can define things. For example, let's see, one of these I can open. Like for example, if you're not familiar with Synapse and pipelines, this is our Azure Data Factory. This is what they look like, right? So integrated with the whole environment is also the Data Factory pipelines functionality. So you can create your own ETL stuff inside the Synapse workload, and you can call Spark notebooks from this, and you can create these notebooks as well. They're pretty good. It auto creates this table of contents based on your um, caption cells in your notebook, so you can navigate it pretty easy. This is one that I use for some of my trainings, and you can add visualizations as well to these if you wanted to. I don't know if I have any of these that have results saved, maybe not. And then the other thing to keep in mind that's pretty cool is that Synapse is integrated with GitHub. So you guys see here, I got my little GitHub icon. I'm in my main branch, but I could create a new branch, and it's integrated with my GitHub. So again, it'll go out and create a new branch in my repo, allow me to develop against it, then allow me to merge back into the main branch. So it has that source control embedded into it as well with an actual integration with GitHub. It could be Azure DevOps as well. I guess it's never loaded. Well, whatever. Anyway, So let me go back here. Data science and engineering. You'll see, for example, Spark, Databricks on the other side. For example, if I want to open this fine-grained forecasting notebook, right? So it's here. If I want to open another one, right? Let's say this one. Then you'll see it kind of like it doesn't do the tabbed interface. I had to switch from one to the other, right? So that's something that I think Databricks has said we're working on it to make it work more like this, right? Where you can have more than one open at a single time, because people get used to this tabbed kind of thing. But at the end of the day, Databricks is their big advantage, or the reason why people adopt it mostly, is first, they do have the full ML integration. By the way, you can integrate Synapse with Azure ML services too. It's just not as tightly integrated as how it is here on Databricks. And then second is, if you're going to do the lakehouse architecture and use Delta tables with Databricks, Databricks again has all the proprietary stuff to do that. Whereas in Synapse, what you use under the covers is the open source Delta tables, not the that Databricks proprietary ones. So there's some things that Databricks can do with Delta tables that Synapse cannot. Okay. All right. Well, that's a lot of stuff. I guess I'm gonna 6:51. So let's just wrap it up. We can go into some questions. So a quick recap. Again, Spark is the de facto open source big data engine. If you want to call yourself a big data engineer, you definitely need to know Spark. Main ways to run in Azure: HD Insight, Databricks, and Synapse. I think HD Insight is a non-starter. Um, Most people run Databricks or Synapse. Do keep in mind, like I showed in the demo, the Databricks SQL endpoint, it is pretty early right now. That doesn't mean that you can't run SQL on regular Spark though, right? The Databricks SQL endpoint is that special proprietary SQL engine that I mentioned in the slides that was redeveloped in C++. So once it's up and running, it queries a lot faster, but it still takes a while to spin up, right? So this is where I find that Databricks is still running behind. If you want to just do a SQL only workload and you're trying to compete with, Synapse or Snowflake, for example, then Databricks needs to increase the speed that these clusters are created and destroyed, right? Um, but if you're just going to do Spark, regular Spark, or just Spark SQL, regular Spark SQL, and you're okay with the Databricks life cycle and how long the clusters take to come up and come down, Databricks definitely has the most attractive proprietary stuff to do Lakehouse, to do these Delta table implementations, right? And so choosing one of them is depending on your use case. As I said, I don't think most people will choose HD Insight. However, I do see Databricks and Synapse being deployed for different reasons. Clients that want to go all in on Spark and the ML part of Spark, and they are bought into the Delta table architecture, then they'll go with Databricks. And clients that are not bought into the lakehouse, that are looking to still implement the classic warehouse, but they want to keep the door open for Spark and then use Spark sparingly too, then they will go for Synapse instead, right? So it's really dependent on your use case. I think both Databricks and Synapse are good products. For, they just have different strengths and weaknesses. All right, so I'm gonna stop here and we can do some questions.
All right, thank you, Warner, for that. We do have two questions on the chat right now. The first one is
Let me turn
from
on my camera again.
yeah, I think that
There
will
we
be
go. I'm
better.
back.
Yeah, there you go. Yeah. So the first question is from uh, Joel. So for Databricks, do you need to load the data into Databricks, or can it process data from anywhere?
Uh, yeah, so you can process it from Azure Cloud Storage, right? So you can. You have to define an integration. So basically, you have to define a credential and a key vault, and then you can give Databricks permissions into that key vault so that it can connect to your cloud storage. But once you're doing that, I mean, you only do that once, right? And
Mhm.
after you do that, then it can go out and get stuff from your cloud storage. Um, I believe Databricks also provides some built-in storage on it, but I never use it because why would you use it instead of cloud storage? Maybe it's just easier to access. You don't have to do that little configuration bit. But if you're gonna do it, I mean, if you're gonna be serious about it and use Databricks for a real workload, you're just gonna use cloud storage anyway. So yeah, so the answer is yes. You would just have to set up the integration, and then you can load and unload data from cloud storage.
It can be from any cloud storage, right?
Mm.
S3 or
Yeah, as long as you can reach it, right? Because I mean,
mm,
how do you reach S3 from a notebook that is running on Azure Databricks, right? You have to expose that somehow um, to your Azure, either to your Azure VNet, or God forbid you just open your bucket to the internet,
to the public.
and
Yeah.
then hopefully hopefully you have a really strong password key on it.
Mm,
But anyway, technically, yes, technically it supports all three, right? Because you can run Databricks in all of the three main clouds. It's not just
mm.
Azure, right? You can run Databricks in AWS, and just fairly recently, maybe like just like 6 months ago, you can run Databricks in Google Cloud too.
Yeah. So that means from everywhere. Yeah. So the second question is from Rachel. Does Synapse also have terminate when not in use feature like the one you showed for Databricks?
Yes, 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 it does. So that's the other thing, right? So both, in my opinion, both Databricks and Synapse, they are pretty good in the lifecycle management, in the sense that they spin up and spin down when you need them or when you don't need them.
Hmm.
It's just that in general, like what I mentioned in the demos, is the spinning up of Spark clusters in both Databricks and Synapse still takes a while, right? You gotta wait 2, 3 minutes for that to come up. And depending on what you're trying to do, that might be annoying for some users that are used to, SQL. Oh, I have a
Yes.
SQL
Sure.
database always up and running, right?
Mm.
So I don't have to wait to go in it. And even if you use the serverless SQL DB, for example, is pretty fast, right? Even if you're not using it, you throw a serverless query, you only wait a few seconds, and that's it. It's up and running, right? And if you use Snowflake, it's pretty much the same, right? Snowflake, especially the smaller-ish warehouses on Snowflake, they go up and down too, depending on if you're using them or not. But when they're down and you want to use it, it spins up pretty fast. In 5, 10 seconds, it's up and running, right? So
Mm.
yeah, that's the only thing. Spark clusters in general, they're kind of slow to come up.
All right. If anyone else has any questions, this is your chance to put it on the chat. Or if you want, you can just unmute and ask the question.
Yeah. And if you think of anything else, feel free to reach out to me directly. You can reach out to me on Twitter, LinkedIn. I get people asking me stuff. I try to get back to everybody, 1, 2 days. So feel free to reach out over other channels if you think of other stuff later on. Okay.
Oh yeah. Yep. And so, thank you, Warner, for that session. For our attendees, the QR code for the evaluation survey is on the slide. Uh, so if you want to put in an evaluation for the session, kindly scan the QR code or go to the link. And with that, thanks, Warner.
Thanks,
Mm.
everybody. Yeah, absolutely.